Yeah, well, welcome to the last talk, which well, last and not least. We're delighted that Yejin agreed to do this talk. Yejin is at University of Washington and NVIDIA. And she's worked on a lot of things about LLMs, including common sense reasoning and what LLMs do. And she agreed to, she was very sporting about this, she agreed to give a talk with very ambitious goals about where we could, what we could expect LLMs to do in the future, or what's missing and what we should be thinking about. Is that the reason?
Yes, some approximation of that.
Thank you.
Okay, so Umesh has a way of prompt engineering me to give a talk that I wouldn't do otherwise. So he did that last year, which was this talk here, about a year ago.
Excuse me.
Sorry, I'll start over. Okay, so Umesh has a way of prompt engineering me to give a talk that I wouldn't do otherwise. So this is last year, jailbreak. Yeah, I'm jailbroken. So last year I gave this talk, Possible Impossibilities and Impossible Possibilities. And then from that talk and also the panel, I felt like there were a lot of these loose ends that we need to follow up. So this is a sequel of that talk. And we're going to revisit some of the key questions and then some anecdotes that I can share with you. Though, to be honest, I feel like I just have unlocked even more questions than finding answers. So if you feel more confused at the end of the talk, you're with me. And also, in all honesty, this talk includes work in progress and thoughts in progress. So I'm not going to be able to give you a definite answer to anything, but just to try to confuse you more. So my original plan was to talk about 4 things: creativity, compositionality, and the rest. But now I realize how many questions tend to pop up in the middle of the talk, and also that I end up making way too many slides. I probably have to give up on pluralism minimally, if not more. So let's start with creativity. So this came up in last year's panel, in which I randomly plugged in this thought experiment, Hemingway's thought experiment, which was trying to get to this question of, might there be different types of creativity or novelty such that there could be something more interpolative or extrapolative? By the way, it's super hand-wavy. Either it makes a lot of sense to you intuitively or not. I agree that it's a very hand-wavy, whatever that means, mathematically or theoretically or otherwise. But more concrete question that I was throwing was, suppose LLMs are trained on all of the internet text minus the work of Hemingway or any other authors after Hemingway who was influenced by his style of writing. Could LLMs, in principle, if with a lot of GPUs, a lot of compute, a lot of data, achieve that level of creativity on its own? So, this was a question that I since repeated in many other occasions as well. I'm kind of curious, what the audience think about this question. Like, do you feel like this should be totally doable with GPT-5, 6, 7, or whatever, Claude next version? Yes? No? So I would just say about half and half, and then a lot of people without raising hand because, it's hard to guess. So the panel was not really about that, by the way. We were wandering around the different topics, but, eventually Shafi was like, can you go back to the discussion? And another way to rephrase the same question, I think, is that might there be fundamentally different types of creativity? And how do we even think about that? By the way, some of this, yes?
Specifically reconstruct Hemingway or just have something equally creative as Hemingway?
I mean, which aspect of Hemingway's writing do I even consider creative is very personal, in the sense that in my one-on-one conversation with very many people, I realize some people don't even consider his writing all that great. So, depending on whom you ask, I realized that the novelty and creativity is really in the eyes of a beholder. But I am generally just using this as one example in case this helps us to think about. But otherwise, just in general, might there be different types of fundamental different types of creativity, such that just the scaling things up will not get there, versus anything will pop out because technically anything is possible with the generative AI. And in all honesty, I do not have an answer to that question, but I will show you some small step toward that. Anyway, so when I ask this question, I get lots of no, or most definitely no. Especially people who don't care about his writing style, or think very little of it, for that matter. But Shafi kind of gave me this signal that, oh, maybe yes. So I like that, and I felt like I need to dig into this more. But one of the common reasons given to why there's no limit to LLM creativity is oftentimes due to this AlphaGo example. This was really like something beyond and above what human experts were considering possible, and this was genuinely creative. Therefore, a lot of people wondered, anything else is possible, and Hemingway is just like another human being. So we don't know the answer, but maybe I can think about it from this angle. So Yanu Kun at some point tweeted that, or posted that current LLMs are trained on text data that would take 20,000 years for one human being to read. And this actually was in the context of how LLMs are therefore not, that great compared to human intelligence, because it's too expensive in data consumption. But we can also turn that around to ask the opposite question, which is, well, in general, if you read more, that's the source of creativity. So might it be that it's just a beast that's impossible to beat because it has read so much more? So which is which, really? It's very confusing. And it's even more confusing when we see, conflicting research results such as this, where, on one hand, we hear that, oh, GPT-4 is already more creative than us. And in their experimental setting, this is true. So for some divergent thinking task, they found that, well, LLMs could really do better. But I also have an opposite study that says otherwise. So this work was collaboration with Tom Griffith and Princeton, because it was somewhat inspired by cognitive science experiments. And this is really about, MacGyver-like situation where maybe you have different objects that you could use in order to solve a particular problem using tools in a creative way, or using objects in a creative way. And in this setting, when you do evaluation very carefully, I'm not going to go into the details of this, there's a lot to unpack, but just let's say that best human is better than best GPT-4. And there's a lot of other, experimental situation as well. So it looks like, GPT-4 versus humans, we're kind of like on par depending on how you measure. And in that context, answering this question, especially in a more like limit sense, like, what the next version of the frontier LLMs might be able to achieve is really hard to reason about. I'll just admit that. Before I show you my new empirical results, I just first mention that we don't know for sure. I have my own bias, by the way, my own speculation that I personally believe that there are two different types of creativity, and one type is just easier for generative AI by design. We just don't know how that mechanism works, and it would be wonderful to figure that out. And Soria gave a wonderful talk earlier about, yesterday about diffusion models, but there might be more to it that we can reason about. But in principle, if you plug in different kinds of reasoning algorithms, decoding algorithms, of course, you could push it further. Anywho, there's this question of how do we even measure creativity? So that question is as hard as measuring human intelligence. So I don't expect that what we are about to present is the only way of doing that. But we present a measure by this work. This is not on archive yet. I will archive in a few days. It's almost ready, but not on the internet yet. So AI as Humanities Salieri. I don't know which emoji is Mozart and Salieri. One of them is Mozart. All right, so what do we do? Yeah.
I think if you think that humans and AI are comparable in the level of creativity as it stands now, right, then it's very clear that AI will be good.
I think they're different. And also, by the way, humans are not identical. We're all different. Actually, there's a beauty to it. But I will not argue with you about which is better, who's going to win, etc. Because I think humans are not identical to begin with.
They're about the same.
No, I actually don't think it's about what I meant by on par is depending on how you measure, you get seemingly contradictory results that are both true. I think we have different strengths. Anyway, so imagine a prompt that says, draft an abstract for a paper with the following title: Poetry Will Not Optimize, or What is Literature to AI? So ChatGPT produce seemingly pretty good text that some might think is better than their own writing. So here what I show you is that a lot of these seemingly great phrases are coming from the internet. So I'm not yet telling you how we did that. I'm going to tell you in a few slides down how we did that technically. But for now, what you see is the advancement of the technology has led to the. So if you look at that top corner, we see the internet text that says the advancement of technology has led to the, okay? And then here's another piece that starts with led to the integration of artificial intelligence in various, and that's this portion, okay? So we can find exact verbatim matching of any phrase of any length back to the internet text. Not only we can do that, we can also do that for near verbatim match. That's not exact. So here, into the complexities of poetry and the limitations, and then if you look at the matched text, the leading preposition is slightly different. It's about the complexity of poetry and the limitations. So we can do this for the entirety of the document. Okay, so how does this compare to human written article? So this is by Professor Michelle Elam at Stanford. She's a professor of English literature. And so this is an actual article of hers about literature and AI. So if we try to match this, it doesn't match as heavily as what ChatGPT generated. There's some portion that did match, but this is a little bit more generic portion. The rest, things like non-commercial creative expression challenge, the techno-instrumentalist approaches to language. So this is a little bit more unique, it seems, compared to ChatGPT. Now, some of you might think that, but GPT-4 should have been used. Yes, GPT-4 is better than ChatGPT. So if we use GPT-4, indeed, it's a little bit more creative in that, less is matching. By the way, this is only a measurement with respect to how much of internet data that we collected, which I speculate is a bit too small compared to how much GPT-4 might be actually trained on. So the measurement has errors in the sense that, I may not be matching other parts because of lack of data access. All right, so Hemingway, how about Hemingway? So this is the first sentence of The Old Man and the Sea, which is, he was an old man who fished alone in a skiff in the Gulf Stream, and he had gone 84 days now without taking a fish. GPT-4 continues. He knows about this story because Santiago, that's the correct name. But it goes, a man of the sea whose weathered face told the tales of storms, weathered and battles with beasts of the deep. Each day he would rise with the sun, silent silhouette against the soft pink hue of dawn. I think there's something off about this tone of language. And And it kind of, some of this sounds a little bit like overly decorated and familiar in some ways. And yeah, they are coming from some other articles on the internet. Ernest Hemingway himself, like when you read this kind of a text, it may seem very plain in a way. Let me actually read a little bit. In the first 40 days, a boy had been with him. But after 40 days without a fish, the boy's parents had told him that the old man was now definitely and finally salao, which is the worst form of unlucky. And the boy had gone at their orders in another boat, which caught 3 good fish the first week. There goes. And there's something like so plain about this language, but at the same time very unfamiliar about the way that he crafts all these very simple words together in a very unique way. So we, by the way, do duplicate removal. Of course, we shouldn't match his own book onto his own book on the internet because the licensed data is available on the internet. So we do duplicate removal. Is there a question? Yeah. Yeah.
I'm a bit confused, but this is from GPT-4. GPT-4 doesn't include Hemingway. So what do you mean by duplicate removal?
Oh, so what we do is we try, when we get an n-gram matching, we look at the whole sentence and see whether the whole sentence has to be an exact quote or exact duplicate copy of that.
So I guess my question is still, I'm a bit surprised that you didn't, why didn't GPT-4 just spit out the Hemingway? GPT-4 knows this.
So, yeah. So, no. If I ask it to generate the first paragraph of the Old Man Does See, then it does that verbatim because it has read it. If I ask it to continue that first sentence, there may be something about safety alignments such that don't regurgitate the copyright material too much. So I don't know why that's the case, but it's not doing it as much. And it's sometimes rewriting the original text quite closely. By the way, there's a randomness to the samples, depending on when you ask, not even how you ask, depending on when you ask, you get different answer. But I found that in general, it makes the writing worse in terms of novelty score. It just wants to use more familiar phrases, even if it's like reconstructing it quite closely, which I found quite entertaining personally. Yes?
Did you experiment with the temperature?
So with temperature, of course, the things will change. So I'm not going to... all of these are very much like I said, even with the same temperature, by the way, if you try again, you get different answers. So all of these are very messy to measure. But in general, we found that, it tends to look more familiar. As in, the things are more retrievable than before. And we can also, quantitatively measure this. I'm sure that you guys all have different ideas about how we should do this. But here's one thing we did do. That we named as creativity index. That's a summation over L uniqueness, where L is, A usually 5 and B until 11. And we basically measure the portion of the words that's outside of this colored text span. And then we take different minimum n-gram that should be matched. And then we sum over that. So when
I think for example, for like say Ernest Hemingway's work, were they compared only to material from the time before Ernest Hemingway?
Excellent question. There's a time cutoff problem. So the internet data we were using has particular time cutoff time, and then different ChatGPT versions have a different cutoff time. And then the way that we do actually is very compute-intensive job that we do very compute efficiently. However, it's still expensive to do. And so at the time of doing a lot of these experiments, we were using Red Pajama, where the time cutoff was 2021. So we didn't want to test the GPT-4 against Red Pajama because it read the text from 2022 and 2023 that we cannot dedupe. So as a result, a lot of these experiments I show you is ChatGPT. But later, we managed to build index for larger corpus. But even so, we don't know what GPT-4 was actually really trained on. So this is approximate at best. Yeah.
And also for like Ernest Hemingway, I would presume like people who came after him would probably have.
Oh, yeah. So So I would say in general, the index is inflating, like it's more flattering measure to have. Yeah.
Sorry, the question is like off topic, but I wonder how hackable this creative index is, in the sense that Hemingway became Hemingway because he got published because he had a unique style of writing. So I wonder if you could prompt the model to say, hey, this is what I want you to do. I want you to maximize your creativity score. Would that prompt change the experiment?
Oh yeah. I mean, you can. I did try. They're just. I didn't want to make this talk entirely just example after example after example. So personally, I did try different things, and usually what happens is that it does help. But do I really like the text? I mean, usually the text becomes very over the top in many ways, in the wrong way. I mean, it's impressive crafting of words. Still, I in a way appreciate that it's doing things that I cannot. But do I really feel the flood of emotion that I first felt when I read The Old Man the Sea, that I couldn't really describe? Why am I feeling what I'm feeling? I just don't get it. Yeah.
If you go back to the text.
Yeah.
So I am an English major.
Oh.
My PhD is from around the corner.
Okay.
So what you're feeling is, and that's not necessarily always captured in n-grams, is the cadence. So what's happening is
Yeah.
Hemingway is you have a cadence where you feel this wrong. And so what happens, especially in early creative writers, is that they just want description and they don't think about rhythm and stress and unstress.
Right.
So where Hemingway excels, and we all write like Hemingway now. For us, there is no before Hemingway. If you look at what before Hemingway looks like, it's kind of awful.
Oh, I see.
So it's, I would probably say n-grams when ChatGPT or when things get into cadence and into rhythm and stress. That's what a lot of the craft is layered.
Gotcha. Yeah, thanks for sharing. I mean, I feel like that's one big aspect of appreciation, and then I also feel like there's something else going on, which is the down-to-earthness of his writing. That is just surreally, unusually down to earth, at least to me. So, but anyway, we should kind of move on because, like I said, I have a lot. But yeah, caveat is that creativity is in the eyes of the beholder, whose eyes, in this case, data's eyes. So if you have a lot of data, then the index will go down. With smaller data, it's going to look more, flattering. And especially, we don't have access to the post-training and alignment data, so that's not good. Index, yeah. So how do we compute this efficiently, though? Actually, this is really non-trivial to compute if you try to do it in a vanilla way. I mean, it may seem easy because, just find the n-gram match. But doing that over really a lot of tokens, 3 trillion tokens, is computationally infeasible. So we, of course, need to do this in a more algorithmic way, dynamic programming way. And we have 2 different components, verbatim match, near verbatim match. The first one is based on Infini-gram. I'm going to tell you what that is in a few slides down. And then the near verbatim is based on world movers distance. And I'm going to totally gloss over the details because I'll just give you the intuition of how things work. The intuition is very simple. So there might be starting position and then end position of any n-gram phrase that you want to match in a running text. And so we move, start position, end position, one at a time, depending on whether that cell was aligned or not. So we can do this sort of reusing the computation. We're not repeating the same computation. So that it's done in a polynomial time as opposed to doing in a very brute force way. Okay, so, yeah?
There's another way that you can do it through B2Beauty FM index. This is through when people has a long genome and has billions of small bits, and they want to mash it against it. And I think this is the current way that people use this function.
Yeah, it might be that what we did is very close to what already exists. I mean, when we developed this algorithm, we felt like there's nothing that's exactly what we did in the, at least like NLP literature. But on the other hand, it seemed like this is just like, there must be some, we couldn't find exact literature. We were trying to find something to cite as exact copy of what we did. But yeah, let me know if you know exact literature that I should look at. But anyway, we found that if we compare amongst like human professional or distinguished writers to ChatGPT or language models in general, then humans, at least the professional writers, tend to be better than the LLMs that we measured. In fact, not only that, yeah, we can hear the index is right now scaled a little bit. So 5 is the best and 1 is the least. And you see ChatGPT versus GPT-3. And sometimes this weaker, smaller model can appear more creative or less memorizing the internet text, either because it may have not seen as many documents or because it's not memorizing as much. But anyway, so we have these experiments. We found that once LLMs are RLHF'd or aligned, then their creativity decreases substantially, which is not surprising. We all feel like, ChatGPT became very lawyer-style language model. And we also did, especially focusing on books published in 2023 after the data cut-off time. And these novelists, maybe are, some of them are in the process of getting famous, so they might have a different level of success. But in general, we found that, again, let's see, their creativity is here. The classical literature, that's like, the humanity agreed that these are really, really high quality or, exceptional work, then, it's higher. And then popular fiction somewhere a little bit below than this. Okay.
It's very hard to go for books to be better. I mean, everything has been written.
You never know. That's a depressing way of looking at the future. But either ChatGPT will come up with something amazing, or another human. I mean, usually these writers can be very exceptional, though. So I'm counting on human beings, different from each other.
I'm just saying because of the history, it's very difficult.
Yeah.
Right, so
yeah, true. But I mean, the other thing about humans' creativity, though, is that you don't have to read all of the. I mean, I kind of feel like the most creative person is not necessarily the person who read the most number of books in the world. And it may be that they just have slightly different wiring in their brain or something. Anyway, so the creativity index can be also used as a zero-shot machine text detector. It actually works quite. So what we did was we generated some text from GPT-4, for example, and used that as the reference text to do attribution against. So if we do that, we found that it's actually quite surprisingly good, such that it's better than Detect GPT or Ghostbuster, which are some of the previous SOTA models. We have an online demo. If you want to try online demo, the URL is a bit hard to copy, but you can find it. And here, the example is Soria's example of Einstein, I don't know, space-time in, general relativity, in a poem setting. So I tried that. And here's the result. So this is L uniqueness at n equals 5. So it's like matching n grams, 5 grams and above. And so you see some of them are matched. If you increase L6, that's like minimum n gram as 6 and beyond, less is matched. And then, 7 is even less. So by the way, these are not word level. This is token level, which is why you don't necessarily see 7 words. These are like different tokens. It's actually, some of these are chopped quite thinly, which is why these are like 7 grams. All right, so corpus supported in our demo, though, is likely to be too small for the frontier models. So take the numbers with a grain of salt. And then all our experiments, although we do remove duplicates in our experiments, not for this demo. Duplicate removal is way too compute expensive, so we didn't do that. So don't get too excited when you realize Hemingway is not creative at all by this. It's not doing duplicate. Yeah.
What you find striking here is not the fact that it used these given pieces.
Right.
You could imagine you were told to do this task with a few fragments of poems sitting around. The thing I find striking here is that it managed to keep a sense of the larger sense of the of the concept moving through the poem. That's
right.
Interesting.
Yeah, sorry that like I said at the very beginning, this is a small, tiny step toward because the creativity is not just about n-gram uniqueness; it's also about the flow. And then even for the flow, I have a hunch, by the way, that there might be a bigger chunk getting copied over, or there might be like two different representative styles getting merged over, and all of these are still to be studied. Like it's not done yet here. I'm presenting a tool that could be a step toward getting into that kind of investigations, data-driven investigations.
Actually, I was hoping you would say that. Yeah, I was hoping you'd point to something saying, well, here's one piece, which is the fragments, but there's some other piece which is also getting copied over in some way.
Yeah. No, we're working on that, but not in the slide. Maybe next year.
I find it's hard to distinguish between creativity versus glitch. Like diffusion model generating 6 fingers.
Yeah. So excellent point. Actually, the study of creativity from psychology perspective is that it's very important that creativity there's a lot of unique or unusual ideas that are bad. So in that sense, fingers being 6 may not be a form of creativity per se, that it's more like a mistaken understanding about the world from the generative AI perspective. So in that sense, this way of measuring things, it's only a rough approximation of what it is. But I would argue that perplexity that people use for language model quality measure has the exact same problem, which is that it's only looking at just n-gram probabilities, nothing more than that, and hoping that that happens to correlate with other qualities. So I fully admit that this is not the true measure, but let's remind ourselves that we don't even know how to measure human intelligence. We never agreed that it's actually there's a one measurement that actually works. I personally believe that there's no such measure that can really just do some kind of exam on humans and then do measurement of your intelligence. There's no such benchmark. And similarly, it might be that creativity is the kind of abstract concept that is really, really challenged to measure by a benchmark. But we can still try to get some grip over what is exactly the Gen AI is doing well, not doing well. When it's doing well, why is it the case? In order to understand that, we somehow need to find some tools and measurement. Yeah.
I completely agree that there's no single you can define creativity, but it seems that to me there's creativity, and I'm surprised that you chose Hemingway as an example of creativity and not like a scientist or an inventor, which maybe no, seriously, because if you look at the examples from both AlphaGo and MacGyver, that seems like somehow going in a different direction. That actually creativity and problem solving, and which is not, to me, nothing to do with repeated patterns.
No. There's different types of creativity. I should have said that this is linguistic creativity that we are studying, not like your other types of artistic creativity or conceptual creativity or scientific creativity. In the paper, we do say linguistic creativity, but I forgot to insert that word. Yeah.
So plugging. So you are saying that for linguistic creativity, there are 2 types. Is that what you're advocating?
No, I think more broadly, there are the kind of generative AI creativity that we seem to see, linguistic or not. There might be creativity that's more interpolative in nature, and there might be things beyond that. That's just not mixture of existing data. Or, this, I think Surya was just saying jigsaw puzzle version of the existing data points. But, that's my speculation in all honesty. If you, feel like that's so ill-defined, I agree with you. But I'm fascinated by this question regardless.
Yeah.
All right, okay.
Creativity. But what about defining not creativity? So if you generate it by an LLM, it means it's not creative? I just want to make sure.
No, I think, I don't think, I never really meant to say that what LLM did is not creative. If we feel that, there's, amazing creativity in the output and we as a human appreciate, I think it's a wonderful thing. And it oftentimes does do better than what humans can. It's not like it's worse than all humans. It's only worse than very select humans today in many ways. So, but, the study that I'm presenting is just demonstrating that professional writers seem to be better in some measurement. The professional writers, are they truly creative? That's another story. Because some of the authors that I included in our study, people may have different reactions to them.
Isn't it fair? I don't know how you would quantify something like that, but it seems that you identified this less predictive with better writing. Is it a fair way to put it?
Not necessarily. I didn't mean to necessarily buy into that. I see that, maybe lesser frequent is better. But, you can always just purposefully generate gibberish wrong text with very low probability. And that's, the earlier question, which is that there's like just bad output that doesn't have value. So usually creativity has to have some value appreciable by other people. And, this all becomes very subjective because, people may have a different appreciation as well. But it's a little bit similar to, in some sense, intelligence. Who is more intelligent? It's hard to really pin down on that either. Yeah.
Sorry, where was your source data collected from for like graphs? Red pajamas, you said?
Oh, red pajama in our paper, but in our online demo, we also support DOMA. You can select, and other sources as well.
I was just wondering about the biases in that corpus as well.
Of course, there's a bias in the corpus, which includes like the fact that it doesn't have the direct access to some of the frontier models' pre-training data and their post-training data. But otherwise, these data sets are, some version or subset of internet data that the community has collected and used.
As your base data, like it would completely flip.
Yeah, of course. But, creativity index, the way that we measure is really a function of the length of n-gram that you select, as well as which data set you measure against. That's what I meant by creativity index is in the eyes of the beholder, where the beholder is the data set. Yeah. Okay, let me move on because I am like falling so.
Later after the talk.
Yeah.
After the break. So.
I kind of knew that it's gonna go slow, but okay, Infini-gram, finally. Let me do it super fast. So, last year panel, there was some discussion about how transformers might be a computer. That's what Ilya said. And n-gram, the old-fashioned n-gram is so inferior, which is true. But, maybe it's a time to update our skill set or technology with classical n-grams. So what if I told you I'm going to build n-gram with n, infinity, on web corpus, more than 3 trillion tokens. And then n-gram lookup speed got to be less than 100 milliseconds. And I'm going to do this without GPUs. This should sound very hard. Okay, so suppose you might want to do n-gram, classical n-gram building over 5 trillion tokens. You need to, roughly speaking, build index over 3 quadrillion or data structure over quadrillion unique n-grams, that might take 32 billion bytes disk space that I don't have, you don't have, maybe tech companies do, but that's really hard. Okay, so you're not going to do this in a classical sense. We have to do it in the novel way. By the way, let me tell you what was the previous largest such n-gram built and shared publicly. The largest one previously was from Jeff Dean and others at Google in 2007, and they built it over 2 trillion tokens, where they had 3 billion unique n-grams, where n was equal or less than 5. So it was very short n-grams, but already you're dealing with this many entries in your database, and that's really large, right? So that's what previous people did. But now we want to do with n equals infinity. So you have an Infini-gram demo here, infinigram.io/demo. So suppose you want to look up this word that I'm not going to try to pronounce, but it does exist. It has 45 letters. So you search that in this demo, then you realize that, wow, people actually said that word more than 3,000 times. And you can also get exact tokenization of that one word, which consists of, I don't know how many tokens, like tens of tokens, 17 tokens. And you get 5 millisecond latency, so that's pretty good. You can also do n-gram sequence search if you want. Actions speak louder than what. And it shows what follows next. Okay. You can do many other things. So you might wonder, how is this possible? It's supposed to be impossible. Yeah. By the way, the lead authors, Jia Chen, and the lead authors are Jia Chen and Sewon Min. And Sewon is going to come at Berkeley. So they're the genius to come up with this, data structure that will actually make this work. So text corpus, this is text corpus, and we're going to build this suffix array, which will kind of look like this. So each entry has some strings or text span from your corpus that you're trying to index. And you see the rank. Rank is just like the order of items in this rows. So ignore that. Pointer is, where the beginning of this text span is. So, of course, we don't really store this portion. We only store this portion in the disk space. So what we do actually is that we just never compute n-gram in advance. We just build the suffix array. And then as you ask about any of these n-gram related statistics, on the fly, we are computing that. That's how this works. And you can look at the paper for more details. But when we do that, how efficient is it for 1 trillion token? So indexing costs $500 on CPUs. Inference, serving inference, about $600 per month. And like I said, no GPUs. It's super fast. The only thing, though, is that storing this much data and equally large index in itself is a bit of a hassle. So there's that. I think I'm gonna just say that you can use n-grams for infinigrams for potentially many purposes, including enhancing your neural language models by interpolating that with infinigram to get better perplexities and potentially many more use cases. But let me just skip over that. I heard, by the way, Dan Drofsky at Stanford is integrating this into the NLP textbook. So maybe this is one step toward making classical n-grams better. All right. Yeah.
Now you're too constrained. You've overfitted. Is that not correct?
It is very true, but you can still use that long n-gram for other reasons, especially when you integrate that with neural language models. Neural language model deals with very large context anyway, and we're only interpolating between the two. So there can be other creative uses.
Exact match or like some mismatch?
It's exact match. Okay, so compositionality. It's a recap. So this, the talk that so this portion, the faith and faith paper, was from the previous year's talk. And maybe some of you have seen this part already, so I will go over this part super fast and super brief. But for those of you who haven't seen, or people who, I don't expect that people actually remember all the talks that they ever watch. I clearly forget. So I'm going to do a quick reminder of this because there are some findings of this work that I'm going to address. So I need a bit of context. Okay, so what this paper was about was the fact that GPT-4 may not do multiplication as well as you thought it might. So, we tried, these numbers, and it's kind of correct, but not really. It looks correct, but if you really check, it's not. Even with this trace of computation, it was not. And it turns out, if you ask 3-by-3 digit multiplication, GPT-4 was about 60% good. And then for longer digit, it becomes near zero accuracy very fast. Okay, and then we also tried the supervised training over 1.8 million, or 80% of that many million examples, by supervised training on GPT-3, and I thought it would do better, but it didn't do as well as I thought it might. So GPT-3, 175 billion parameter model, supervised learning on that many examples, 80% of that many examples, which is enumeration over all these different digit combinations. And the test set is only the pairs that the training set never included, of course. So it's split against 80%, 10%, 10%. I thought it should do better than this, 55%, but it did not. So this is kind of important because I'm going to come back to this. It was only 3-by-3 digit. I'm going to be talking about 20-by-20 digit multiplication in a bit, but this is 3-by-3. And, we also tried GPT-2 from scratch in case this is tokenization issue, yada, yada. It doesn't work either, 10%. Okay, so supervised training on multiplication seemed hard. Of course, some of you are thinking, hey, you should have done Scratchpad or chain-of-thought reasoning. And yes, this does help a lot. So how much it helps is that it really helps. But it doesn't work. I think I missed. So let me just verbally say that it helps a lot, but the accuracy drops near zero again when you try to do longer digit. It works really well up to 3 digit, but 4 digit, 5 digit becomes like 4%, 2%. However, if you do supervised training with the Scratchpad on GPT-3, which if you want to do 5-by-5 digit supervision, I need about $700 million that I don't have. So back then we only spent $7,000, and that showed that it really works if you only do 3-by-2 digit multiplication or less. But if you do longer digit, then 0% again. So I'm going to skip over why this is the case. This is all last year. I will just share the surprising divisive reactions from the community that I faced after this. Whenever I give this talk, I was receiving 2 entirely different types of reactions. There are people who says, I knew it, I love it, thanks for doing this. And then there are people who says, you must have done your experiments wrong. They're very sure. We already did do that. GPT-2 was that. I was going super fast, but tokenization was not the issue. It is an issue, but removing that in itself didn't help. And despite tokenization challenge, in fact, it's surprising how well it does work when it does work. But anyway, so this divisive reaction was actually very not only surprising, but also quite interesting and exciting to me because I never had this situation before for any other talks and papers. Usually people don't suspect your experimental outcome with certainty. And some of this certainty came from people who never run experiments in their work, or people who are not even in AI field. But they were so sure that there must be something wrong in the research that I've done. And I thought this is a really fascinating phenomenon that we're facing as a community. And it really says something about the importance of the research that better enlightens what we don't know and what little we know about large language models. I just wanted to share this. Yeah.
Why did people find experiments wrong? Like, what did they?
They just couldn't believe that GPT-4 cannot do as well as what we reported. I mean, they knew they were so sure that, I mean, some of them had this reaction that base GPT-4 would have done better than the aligned one served in the public space. The other people felt like whatever it doesn't work is temporary glitch, which will just go away in the next version. Some of them seem to have more like emotional reaction that I hurt their precious, friend who, by the way, these people with emotional reaction was never OpenAI people. OpenAI people were chill about this result, but more like people who are not working for the company, but using ChatGPT in their maybe daily life. Huh? What did you say?
Using ChatGPT for multiplication.
Oh, then they would be in trouble. Yeah. Anyway, it was interesting experience.
A lot of kids solving homework.
Yep. Some of the parents with such children felt a little bit heartbroken by this. But anyway, so what I wanted to highlight is this finding. So the summary of the finding is that GPT-4 doesn't do very well, but with chain-of-thought, elaborate chain-of-thought that is actually taught through in-context learning does do better. And then, of course, if you do supervision with that, then it does do even better. Except if you don't do this direct supervision with the COT, chain-of-thought reasoning, then it really doesn't work very well. Even with the 3-digit, it doesn't do very well. Even with the 80% of 1.8 million examples, it still doesn't work very well, okay? So, and that, from theoretical standpoint, seems not unreasonable because, there's papers that says, well, there's a fundamental limitations of transformer architectures when it comes to some of the compositional tasks. And there are some other related work that also says, if you do chain-of-thought, then you can do a lot better, but without it, it's all limiting. So in that context, I couldn't believe when the lead author Yoon Tian, now professor at University of Waterloo, but prior to this position, he was postdoc at AI too. He came up with this weird idea, implicit chain-of-thought reasoning. So what is it? So he wanted to try the following idea that, there's system 1, system 2 reasoning that we hear due to Kahneman, and this is more elaborate, like math reasoning. And, a lot of the times when we learn to do system 2, we kind of start internalizing it down to system 1 reasoning by repeating it a lot and almost memorizing some partial results, and, this does work. And so as a human, you could also learn to do multiplication internally if you train to do so, right? So he wanted to see whether this could be done with transformers. So how he did is kind of weird, but in the end, I'm going to compare these 3 results. So explicit COT means supervised training with explicit chain-of-thought. We know that this does work. We know that this does not work, okay? So this works, this doesn't work. Now, can this work such that during training, you show chain-of-thought, but during inference, the model has to answer the answer right away, okay? There's no printing the model's chain-of-thought. It's all internal. Now, should this be possible? I feel like it should not be possible. But there's a recipe to make this work. So he did some weird training where he first trained with this full chain of thought reasoning, and this chain of thought reasoning is very particular to make this work. If you do regular chain of thought, this doesn't work. So this is very, very particular, but when you multiply 12 with 34, you first need to print 4, which is the end digit of 12 by 4, and then reverse the digit. You see what, this is like somewhat, this is human intelligence doing the work of, like imbuing our ideas or understanding of math down to the transformers. So bear with me a little bit. I know that this feels a little bit like convoluted, but what he does is first train with that full COT, but train with broken or truncated COT, gradually removing few tokens at a time. And then in the final supervision, he's removing all of it. So this is like a very long training. And this is weird training. Nobody, takes this much of effort to like train, this kind of staged training. And in fact, you have to be very careful with some of the hyperparameters, which is a fair deal compared to, how regular LLM training also goes through a lot of black art of picking hyperparameters. So nothing different there. But what results would you expect to see is the thing. So accuracy and speed. Higher is better for both of them. So with explicit COT supervised training, accuracy is 100%, speed is very low. Without COT, accuracy is very low, and speed is very high. Now, what should be the trade-off when there's implicit COT? Like, what do you expect to see? I was certainly not expecting to see the results of accuracy being the same as explicit case. So this was like, whoa. And at first, we did a few digits, and later Yuntian was keep pushing to reach more like 20 digit almost, and it still works. It's weird. For me, what bothers me greatly though is this. When we were doing faith and faith paper, some people were worried that we just didn't push it hard enough because if we trained longer, grokking would have happened. Grokking happens, and then suddenly the network rearranges itself into the correct generalization, and then suddenly everything is accurate. But how do we know whether it will happen or not? And we tried long enough compared to other grokking papers, by the way. Computation-wise, we were not being unreasonable there. We were trying long enough. And I kind of feel like if you do just like regular supervised training without COT long enough, I really don't think you get these network parameters just because grokking suddenly happens. Seems unlikely. But can we actually put some more formal reasoning around it? I'm just like asking you to solve this question. So maybe there are fundamentally two different types of generalization, grokable generalization and ungrokable generalization. We do know that the parameters exist that can do multiplication without doing COT explicitly. But how do we find that without doing this weird training recipe? Yeah.
Is there like a general idea how to do this implicit? Like, oh, this is only for multiplication, you can't come up.
What do you mean?
Recording in progress.
I don't.
Oh, you have to come up with, right now, there's no generalized recipe. By the way, this demo shows how long it would take if you were to do explicit COT, just still computing. And this is our implicit COT demo. There's a web demo. You can go and check if you want. It's weird that this small GPT-2 network can even do this. It just like blows my mind. Like, why should this even be possible? Like, I don't know what to think. Like, how is this possible? Yeah.
You mentioned somewhere that it's crucial to do stage by stage, that mix everything. I mean, did you try mixing all the different truncations together, just training it?
No, that's I mean, we tried the different things. I don't know whether we tried exactly what you're suggesting, but doing the gradual reduction of a COT is important, and it's also important to introduce a bit of noise. If everything is too clean, it doesn't learn very well.
I completely understand.
Yeah.
Order.
Yeah. Yeah.
The COT need to be in your specific order.
Yeah. COT has to be specific order. But ours is not the only one who kind of did this like reverse COT. There were other work that did show that, using human intelligence, if you arrange, like input, output, reverse the manner, etc., then things do work better, and that's another thing. Yeah.
Can you clarify a little bit? What do you mean by grokkable and ungrokkable?
Oh, so the grok is a concept that has to do with like if you train the network long enough, instead of overfeeding, suddenly network kind of like rewires internally such that it's really suddenly doing better for the test setting. Even like out of distribution generalization enhances because it somehow learned the correct principles instead of finding some surface patterns. And there are some experiments in which that was true. But the question is, does it always happen? When does it happen? It's not very clear. And in fact, the way grokking phenomenon was discovered is by accident. The researchers forgot to turn off their machine, and it kept doing training, and it was not supposed to go better, but suddenly, after some phase, it was like way better.
But clearly, that's not all. Like clearly, that sometimes happens. Sometimes
to you, yeah. The thing is, I know. But the thing is, when I presented faith and faith paper, some people have faith to the ability of LLMs. So they feel like, in principle, the language model could have done if something was trained long enough. Like, it's also a fair question to ask. Like, I have a hunch like you that, doesn't feel like it should happen, but I don't know for sure if they're right. I may be wrong.
So when you say grokkable here, I'm just hearing it as learnable.
Yeah.
Is there?
Sure.
Is that the correct interpretation, or do you mean something different by grokkable as opposed to just learnable?
I meant learnable seems hard as of today. The grokking is empirically harder to, validate because.
What do you mean by the difference here between?
Grokking, I'm using that in the sense. Okay, you're using learnable in a more like theoretical sense where it's like ultimately learnable.
No,
Sorry.
I just mean you train the model on data and it learns.
Let's just say, how about this? How about we just say that what I meant by learnable is just like with a reasonable amount of effort, not like pouring all your heart into GPU purchase. Grokkable, I meant like if you put, maybe it looked like it was hard for a while, only that if you were willing to spend more money, more GPU hours, then something would have flipped and then suddenly it works better. Let's take it offline. All right, so there's something weird about this result, by the way. The results is not, yeah?
Pattern matching, like 20 digits, 20 digits. So it's a grokking will never happen. But if you include that in the training step, so it's just boils down to the pattern matching of just 10 digits under 10, adding and the multiplication. So it happens multiple times. It just do this way. So it makes the task much more easier. So because it remembers the multiplication under the 10.
Let's take it offline. I agree that, doing that does make, obviously, the training easier. However, I don't know whether we are providing sufficient answer about whether it's grokkable or not. But anyway, so what this shows is the number of digits in the first argument and second argument, and then whether the result is correct or not. And for most pairing, accuracy is 100. But for some cells, 99.9 or 99.7 or 99.5, okay? So it's not perfect. It's 99.x good, right? Okay, so where does it fail? It's very funny. Hyunwoo is a postdoc in my group who has a way of coming up with this, like, I don't know, intuition to break GPT-4. He usually does it for theory of mind or recently privacy-related stuff, but for this one, he says, let's try 44444. And then turns out, yeah, somehow the network didn't learn that part right. So this is wrong. I have a lot of fun examples that has to do with grad school math that's based on natural language mixed with reasoning, but I'm going to skip all of that and just say that in this context, implicit COT does also help, but it doesn't close the gap against the explicit COT case, either because explicit COT benefits a lot more from the language. Well, there's some speculation about that, but it helps, but not as much. So, yeah, I feel like on one hand, the empirical results were enlightening. On the other hand, I feel like now I found what I don't know even more than before. So I feel like I know less than before. Let me think what I want to do next. So I'm gonna maybe talk a little bit about paradoxes and then end the talk soon. So you might have heard of Moravec's paradox that, maybe chess is actually easier for easier for AI than perceptual tasks like robotics. Today we don't yet have a home robot making coffee for you. What could possibly go wrong? So it seems like somehow what's easy for us can be hard for AI and vice versa. So that's sort of like Moravec's paradox. So building on that, we had the generative AI paradox, that what it can create, it may not understand. So the gist of it, there's a formal definition, but hand-wavy definition is that for generative models, hard might be easy, easy might be hard, compared relative to humans. And here, hard is generation and easy is understanding from human perspective. As in, like, for me, I can read Hemingway, but I cannot generate Hemingway. Even if I am aware of his style, still, I don't think I can. Whereas GPT-4, if you ask it to generate text in Hemingway style, then it will. So there's something astonishing about that. It's true also for image generation models. So if you ask, draw a photorealistic astronaut doing a plank on a table, as a human, I would say I shall not, because I don't think I can draw things like that. I certainly cannot do any of that. But as a human, I know which one I don't want, or which one I know is the best one. So, it's weird how it was supposed to be on the table, but it's like fallen from the table. So this is like easy for us to know like what is correct, but that doesn't seem to be the case with the current AI models. In fact, even with language models, which appear to understand so much, it's doing like amazing job at passing the bar exams and like, acing the medical exams, and that must require understanding of a text, but it depends on what kind of a text, what kind of a question, understanding question you ask. So, in this experiment, we deliberately asked GPT-4 to generate maybe a story of a paragraph or two. So it did generate, this is own story. So there's no worriness about whether, we're asking weird question that it doesn't know about. So then we ask questions like, how many total designs were sketched in your story? And it says, only mentions one design, even though, well, the story itself talked about multiple designs. When the answer is verbatim in the text, usually the answer is always correct. So the text understanding does seem to work well, but when you ask a bit of these corner cases, you see weird flaws coming out of LLMs. So there's something odd about that. And we actually tested this in many different ways, including how we convert QA, multiple choice QA problems in generative setting and discriminative setting, and compare how their performance compares against the humans. And it's not black and white, but we see a bit of a trend here that, the performance trajectory is not the same between GPT-4 and human. GPT-4 tends to be better at generation than the other way. And turns out this is not just a phenomenon that we found. There's another context in which something similar happens, which is the generative AI paradox in evaluation, that what it can solve, it may not be able to evaluate. And it's really fascinating that it seems to be able to solve something, but it may not be able to grade it. We found in our own work similar phenomenon that when you do inductive reasoning, so we were testing inductive reasoning, we found that LLMs are better at hypothesis generation, but it's not able to validate the hypothesis that's clearly wrong as reliably as humans are capable of. Here's another such example. I mean, I'm drawing analogy here. Like there's a reversal curse paper that I really like, where they basically show that LLM knowing A is B may not mean that it knows B is A. This requires a particular kind of example. So, who is Tom Cruise's mother? There's apparently information about Tom Cruise's mother. LLM may know Tom Cruise's mother, but when you present mother's name, it may not know that it's her son is Tom, for example. So that's true even with, in the paper, they talked about GPT-3, but they redid the experiments on GPT-4, I believe, and it's still true, regardless of the LLMs. There's relevant to some of the talks earlier in this workshop. There's also jailbreak paradox, and lots of paradoxes coming up. And last but not least, Alain Sir also showed that LLMs are unbelievably sensitive to the formatting that you use when you do prompting. So if you accidentally included, extra spacing or some punctuation marks, it might actually change the performance quite a bit. And there are two different ways to think about that. One way is, well, it's a human's fault. Why do you have extra spacing? Some scientists actually do have that viewpoint. And then the other way of viewing it is that there's something worrisome about the way that LLMs appear to understand language, or appear to do really well on QA in a certain format, but not in the other way. Okay, so thank you. Yeah.
So do you think that problem with the reversal is it doesn't know, or it can recall?
I don't think it's a recall issue. I think it did not internalize the fact that, it didn't do generalization of some of the knowledge.
Yeah. This dichotomy between generation and understanding. There's a perspective from which it might not be so counterintuitive, in the sense that understanding is sort of like inverting a binary function. You're given, there's some meaning, and going from there to generating something is sort of easy. If you understand something, generating something, or just making up something is easy. But now to understand what it means is this reverse map, which is usually a bit difficult.
The opposite.
Yeah.
But digital signatures, you can verify it, but you can't generate it.
No, but you can compute forward, but not fast.
You're verifying just one, or just 0, 1.
Computing is computing, but static generation.
I
think you can go in both directions. You can prove in both directions using crypto.
I think in practice too we see both. Like some cases one is zero. Yeah, related to the reversal course, this is a plug not for my work, but like the physics of language models paper has some really interesting experiments showing why the models can kind of, like when you say A is something to B, they associate all that information with A. So now when like just like in the parameters, like, but then they just have not associated that information with B because of the autoregressive generation, like and how we train. And so I think they did a lot of control experiments where like this reversal thing is hard. Also questions of reasoning, kind of like, is the year someone's born odd or even, like the model will totally fail. But if you ask what year they're born and is it, odd or even, they can do well. So I think they try to like isolate some of these properties that purely because of how knowledge is stored. So there's some interesting experiments in that paper that try to explain some of this.
Thank you.
So you did multiplication. Did you do division?
No, but we did also do other puzzle and also some dynamic programming problem. For the fate and fate, and not for the implicit COT. Implicit COT, we had some other number-based parity problem we experimented.
Because I feel that if the basics of calculus, right, is plus, multiplication, division, and then you can build up.
Yeah.
So
With no creativity.
without creativity, yeah. Actually, the whole point of mathematics.
Okay. So, given the research you do, what is your intuition? Will an LLM, with the architecture it's built, be able to be a good data scientist? There are a lot of coding elements, there are a lot of elements in there that can be trained, but there is an element of creativity in deciding how to look at the data, in which sequence, what have you. I mean, it's those that study sort of theory of data science, they would argue that it's quite creative. And I was wondering how.
I still think we can do wonderful things using LLMs as a building block. We probably do need to build the things on top. I personally think posing really good question is harder for LLMs to do. So that has to be coming from the creativity of the scientist. But once you pose questions, then you could use LLMs to find some new insights, and that could be quite helpful. But probably it has to be more like collaboration as opposed to just ask ChatGPT to write an award-winning paper on its own. I don't know how soon that's going to happen.
That's actually a good experiment. Write an award-winning paper. That's not necessarily creative, but you could ask that. Maybe with that. I'm not sure it satisfies your definition.
What they say is the correct answer to that question is not the correct answer. There is a typo.
Oh. I didn't know. We can let the authors know.
Okay. Well, thanks again.